Okay, everyone. Well, then we'll just get started. No one wants to tell me where they are from. So this is our fifth installment. I'm Susan Crowden. I'm the Director of Sales here at Vias Corporation. I have Glenn Larson on the line as well, and he'll be doing the presentation today on packaging design. And I also have Danny Alcini from Dassault Systems sitting on call if there are any technical questions that need to get addressed that we're not able to address without him. Next slide. So first, the good stuff. For any of you that have been here before, you know that for each presentation, we give away a $50 gift card. So if you stay to the end of the class, your name will be entered in the gift card bucket, and we'll pick a name and call out a winner right here on the spot. And for anybody that attends all 7 classes, so if you've been to the previous classes as well, you'll be entered to win either a Space Mouse or an iPad. That'll be your choice. And we're going to select 5 winners in total. We're only on class number 5 at the moment. Oh, I see there's somebody. I guess I can't see the chat. So Kenya's telling me that we do have people writing in. Somebody's from Oakland, Tennessee. Anybody else that's on the call, if you want to tell us where you're from, that would be awesome. So who are we at Vias 3D? We're a Dassault Systems Platinum Partner. We are now 4 of the last 6 years a Platinum Partner. We were a Platinum Partner for 2021. We're a Dassault Systems Education Partner, and that's what you're getting a little bit of taste of right here. This is an educational series trying to educate the end user community about the different features and benefits of the various software applications that we're highlighting. We have multiple industry experience in very many different industries: oil and gas, petrochemical, nuclear, a lot of aerospace, a lot of automotive, etc. Our team consists of more than 100 employees, and the team is growing over and over. I think we're moving on to the next one, who we are at Dassault Systems. So for those of you who don't know anything about Dassault Systems, the software OEM, and by OEM is original equipment manufacturer, i.e. the maker of the software. They're the world's leading developer of the CAD/CAM CAE software. They have more than 120 interrelated software products, serving 11 various industries, enabling the implementation, design, analysis, manufacturing, and post-production support systems. They have more than 22,000 people now. They have 12,600 worldwide partners with over 290,000 enterprise customers, and they're about $5.4 billion in sales, so not a small company. Next slide. Our value is at Vias 3D is to help you with the digital transformation process using the 3D Experience platform. We have social and collaborative apps. We have 3D modeling apps. We have simulation apps and information intelligent apps that allows us to analyze, predict, and develop, insights from the data that we're creating. Next slide. So I'm going to turn this over to Glenn Larson, but the key takeaways from this class are going to be, we're going to show you how to create a realistic package design. We're going to show you how to have dynamic control over the package design. That's pretty cool. I'm waiting to see that. And we're going to use the same data model as the design part parameters from the material collaboration through mechanical scenario creation. So with that, I'm going to turn it over to Glenn Larson. Glenn, take it away.
Thank you, Susan. And thank you for coming again. Welcome to our 5th in our series. And we'll start out with one of my favorite apps that I've used, applications that I've used is packaging. The reason I like packaging, I know that in the manufacturing world, all of us have to create packaging at some point, even if it's just for shipping something out. But in this case, we'll go over some packaging needs. We've got our primary package, and this could change depending on perception. Our primary package in this case might be a plastic container with some food or some other substance, and then a secondary package would be the box that it's in, and then the tertiary package would be the how they package that and where they put it. And of course, you can move on to palletization and things that we'll see a little bit later on. But what I'm going to show you here is I'm going to show you what some of the tools are, And then we're going to go through, and I'm going to have to go through kind of quickly because I've got a lot of material. We're going to go through a series of about 10 videos on how to. There's several ways to create packaging. It works much like sheet metal. So for example, if you want to design, you can start from a panel and you can just, bend up edges or flange up. All of these tools are available just like they are in sheet metal, except they're a little simpler to use. So I'm going to go to the next slide. So you can see that you can get a good flat pattern out of it. This is just something I reverse engineered and measured and created. But what you'll see is that how important the cuts and the radiuses are and what can happen. And if you look down packaging design, you can see that, well, first of all, I've got some a flat panel and then a bunch of, edges up or flange ups. And that's pretty much how this one's made. And then I've got some cutouts. And this particular one I parameterized everything. So, anything that you want to control from a parameter you can. And later on, we'll see we're going to dip our toe into simulation and look at how that can be optimized. Some of the tools that we can use, and these will look familiar to you. The carton parameters is right where it starts. You have a choice to use solid material or perforated material or, corrugated cardboard. So you can use either or, and there's some rules, and we'll look at that a little bit in the next couple of slides at what those rules look like. And you can put any number of rules in. It's simple to do, and there's not a lot of scripting needed to do this or anything like that. You can just add stuff. So then we have, of course, a corner extrude, which will extrude a panel up and then a cutout, which any kind of a cutout that you're going to make. Fold and unfold, of course, is paramount to this whole thing. We're trying to get a flat pattern to maybe either use this on a cutting printer, or you're gonna maybe you're gonna create a die for it, a steel rule die or something like that. So you also have fold, which is going to fold from a line just like it does in sheet metal. And then you can actually create glue joints. Now it doesn't really typically, it's not really a constraint. It's really more of a glue call out than a constraint. So when you do simulation, you have to remember you have to constrain these edges. So then you have, my favorite is panel from an edge, because that's the easy way to create things. One of the best features they've put in here, and this used to be separate from things like CATIA and stuff like that, is the nesting software. To be able to tape those shapes and nest them so that you can, if you are creating a steel rule die or trying to save material, you can get as many components out of one sheet of material as you can. So the nesting is a good, we don't get into that into the video here, but it is something to take a look at. And if requested, we could do a whole demonstration just on nesting. So the panel definition, again, it allows you to choose from full or corrugated. Full is just a solid thickness. You can choose the thickness of the material it's going to be, and use it comes with default rules, which are pretty simple and actually pretty accurate. So you can actually create different rules here if you had a different material type, depending on what you were doing. Maybe you've got some, cardboard with wax coating, or, or corrugated with plastic. These things would create different rules. So, and then of course your colors of your cardboard. So when you choose cardboard, it's usually one color on one side and another color on the other, so it's easy to see what's folded. And then of course we have, our panel up. And so you can, just like anything in CATIA, you can go either direction on the sketch. You can be in the center of it, you can be on top of it or below it, and then you can invert it. And then, like I said, my favorite function is the panel up function. This allows you to quickly take from a square piece and panel up your edges and fold the box up very quickly. You can create boxes in just minutes by doing this, if you kind of have an idea on what your dimensions are. or maybe you have some standard box sizes that you can just put in. And again, all of these things can be parameterized. Well, at least height and angle can, and your tangent number. So there are things that, obviously these are pull downs and choices, but the rest can be parameterized and connected just like any other parameter. So the reason I like the panel up function is that you can control whether you're going above or below the area and have a number in there for that. Again, that can be controlled through a parameter. So it's really easy to make flaps just touch and get your exact corner radius. And this is where the cutout's important in the material. This will, if you try to fold this up without a good radius here, it will tear, and you'll see it. And now we're going to get to the videos. So these videos do it a little bit differently. They don't work from a panel. These are going to work from, taking a sketch and with all the folds on it already. And what we're going to show you here is, this one's kind of quick. You're just going to put in the rules and the laws, just like I showed you. And that's how you set that up. Tell it what type of material it's going to be and what your basic functions are going to be for rules. Here they're adding a rule, folding law. It's not that hard. If you know what your data is going to be, you can just put it in there. And so when it folds, it's going to follow that. So the next video is creating the panel. This is quick and easy. You just choose it. Again, you go up, top or bottom, make it go which direction you want, depending on how you're set up. And that's as simple as that. Now, creating a folding standard, this is where you can start to use parameters, and what you can see is what you're going to be able to control here. This is where this tool becomes more important. Because all material works a little bit differently, so you're going to have to come up with what works. And you can see that they've got 3 separate sketches here. One was the panel, one's the cross folds, and then the other folds. And they're going to control these folds a little bit differently. Is what they're going to show you is how every time you pick on an edge, you can choose different rules and laws. This is great for control and optimization later. When you can parameterize these things and you can bring this into, a simulation and see what happens, maybe putting material in it or something else, and you can make changes. Maybe your seams are too tight and they're going to tear once liquid's put in them. So there could be a lot of reasons why that might happen. And, this is why the connection between design and simulation is important for packaging. I'm going to create some folding standards. Or just do that. Using the cut and fold tool. So you have to make cuts. And so here, this is going to cut out where the folds are. It's not going to, it's not going to create a larger radius for something, depending on what type of a fold this is and how thin the material is. That might work fine. Just cutting that out there. It's a pretty simple tool. Managing the fold cycle, this is where it gets a little bit more complicated. So you can see this is where you can you can actually keep this up and adjust these, and you'll get a ghosted image to show you what it's going to look like folded, right? Just like that. So you can actually use the adjust button up or down, and they'll do that here. Get it to put it right where they wanted to put it. So you can adjust those up and down just to see what the result's going to be like, and then go from there. Okay, so the mirror function is pretty simple. They show this twice. I cut out one of the videos because I think everybody knows how to do this. It's just good design to anything that's going to have symmetry to it, to only design the areas that you need to. It's a lot easier to control. And if you don't have to draw the entire thing, why do it? So this is kind of a basic function here they're going to show. Not much you guys don't know. You know, in this case, they drew a quarter of it. And, you're just going to mirror it right on the edge. And then all this. So this happens to be like a protein drink type of a box made out of paper. And you'll see in the next couple videos what it's supposed to look like and how they come up with it. So this is probably very thin cardboard with a wax coating. Right? And so then you get your whole piece. So once you've got your complete component, now, of course, putting this on a drawing is really simple. You just unfold it. And, if you're looking for a DXF file, or you're going to just plug it straight into a cut machine, or whether you're going to nest it. So create your flat pattern. Just choose it. Tell it you want it in the open. And of course, our idea here isn't to show you drawing, but this will give you that pretty easy, so you know what it's supposed to look like. And you can see what they started out with looked much different because they were just doing the quarter of it. But now we can see what it looks like completely unfolded. Okay. Creating more cutouts. They're just going to create these cutouts so they can fold it up. So, and of course, you'll use symmetry on that too. So what you'll find is there's a lot of, if you dig deep into all the tools, you'll find that you have a lot of options. And again, so you'll see in the, okay, so now they're going to fold up the top because we created this and it's still not completely done. So now they're going to create folds for the top. This gets a little more complicated. As you know, if you've ever tried to fold paper together, the more you fold it, the more difficult it becomes. So now is where rules become important. They're going to overbend it so that they can bend it, they can fold it over top of itself. So, because remember, this isn't bent with any equipment or anything. It's just pre-trimmed and somebody's got to fold this or a machine's got to fold it. So they have to give it enough angle to get that fold flexible enough to fold in a second direction. And this is where your control in here is just fantastic. You can see each fold and it ghosts. It gives you a ghost, which we call a ghost view of what it's going to do. And see, you can control these on the screen just as well as you can over here. Let's throw it up. This one takes a few minutes. This is one of the longer videos, but it gives you an understanding of, you know, because this would be something difficult to engineer otherwise. You know, you'd have to do some testing and physical testing. Here you don't. You're going to get a pretty close representation of what you're actually going to get. They're making it look easy, but this will take a little practice. Most of the boxes I've designed from a panel up. Doing it this way, it takes a little more expertise and practice. But as you can see, you get the result, and you can see what the flap overhang is going to be. Actually, if we get back to that real quick, just zoom down to it, just to give you an idea of what I'm talking about. Let's go a little further. So you can see, you know, the overlap that you're going to get. It's going to be realistic. And so your product is going to look, you know, you can make it look perfect in CAD if you're not using rules. And it would fit perfectly flat on there and even, but it wouldn't be right. So this is where the bend rules come into play. And, you know, with this application, will save you a lot of time and money. So one of my favorite parts of this video here is what they do with the label and the tools that we have to, the labels are put on with the texture tool, which if anybody's used the texture tool, you know, it's kind of easy to flip the direction, move things around. And this one here, we've got some great tools. So we're going to pick the surface, and they didn't show you the cutout and the plastic part that they added to it. That wasn't part of this demonstration, but that would have been an extra operation. And you can see, and you know, if I can stop it right there, is that, you know, sideways. And so you can just flip these around in this app. They're just going to put it 90 degrees here. And these slide bars that go up and back will allow you to adjust it up and down and back and forth. So, you know, it's the biggest problem with trying to put a label on or a sticker on. This is a great application to do that. It works really well. And looks great when it's done. And so that is creating that box. And you can see in this case, it does, this flaps kind of hang down like you wouldn't want them to. So at that, we're going to stop, and I'm going to ask Kenyon to trigger a poll for you guys. We've got a quick poll, and when everybody answers, we'll move on.
If you guys don't see your industry here, please go ahead and add it in the chat. Okay, has everybody added their industry? Kenya, what sort of results did we get?
Yes, I will present it, and you can see it on your screen now.
So 29% from consumer packaged goods, 43% from automotive, 14% from aerospace, 14% from industrial equipment, and nobody from high tech. That's interesting. Okay, very good. Thank you everyone for working with us on these polls. We'll turn it back over to Glenn now.
Okay, thank you, Susan. Appreciate it, and thank you for taking the poll, participating. So the next portion of it is kind of a teaser for another webinar we're going to do later on. We're showing you what we can do with packaging simulation connected to design. I think, going forward, you're going to see more and more of what we call mod sim, where the simulation can help drive the design. As we design things going into the future to make things more efficient, and these things are connected, it really makes a lot of sense to use them in conjunction. So with that being said, what we'll take a look at is packaging and palletization validation. So let's suppose your package that you design, it looks great and you think it works great, but when it goes through the whole entire process, what's it going to look like in the end? And so we use a lot of tools to do this. And so, like I said, I know there's probably a lot of people in here in design, but you'll see going forward more and more, some of the simulation tools are available to you in a design way, and then also the connectivity between the people that do the simulation. So in CATIA, we have a lot of very basic tools that uses some simulation to help with the design. We call them, things like functional generative design and such. So the connectivity is there, and here we look at the unit design, and then this would be like a secondary package, and then in this case a tertiary package, because they're starting out with this as the primary. Right? This is already designed. They're happy with this. What's the best way to get this to here without destroying it? And your transportation unit design down to optimizing that. And there's several ways to optimize something like that. You have to look at stacking in a factory, and you also have to look at the transportation of it. And if your stuff is getting crushed or destroyed, all the work you put into making a quality product is out the window. So that being said, some traditional methods of handling this have been physical testing, as you can see. They have handling and drop-in impact, transportation vibration, and stacking and loading. And so you can see that, in the past, companies have spent a ton of money testing like this. And so when really we can do it like this, because of the fact that you're building a realistic package, you've just designed your package in CATIA package design. It's all parameterized, and it's realistic. The corrugated is simulated like corrugated, and the solid is simulated like solid. So now things like plastic can be added to it, and you can see what happens when you drop it. You can see the drop test. You can see transportation and vibration, what happens to things over time. And then, of course, stacking and loading. And this is a big one. I mean, how much can you get into a warehouse? And if you think about this on a really large scale, is a lot of money at stake. Even right down to, if you're making aerospace products and they're getting to your customer, if they get damaged, it's a problem. So it's kind of an important step going forward. Simulation for this is big, and you can look at the palletization of it and what the weight of that is. You're going to know what the weight of that is ahead of time. You can look at that from a cost standpoint of shipping and how you get it there. So that's kind of important. And to take a look at each one of these is a video. I gotta kind of switch back and forth, so I apologize. But I want you to see some of the ways that we've tested them in the past. And you can see that somebody's going to take this. They have to have real material. They're going to run this down, go back and forth with it. And if it falls off or it has a problem, they know they got a failure. Well, they're just destroyed a whole container of material. If that's expensive material, it's a problem, right? And we all know that floors aren't smooth. Stuff gets jarred around. This is only just right. Here you go. Didn't make it. And it's water, so, that happens. So another one was a stop test. You can see this elaborate design to look at stop test. Everybody's standing around wowing how cool that is. Well, it's not necessary. It can be done in software today. You can at least get really, really close. Something happens out in the field, it might be the outlier. And it's just a mess of money being spent in packaging. Some of the other things to consider are the reduction of plastic. There's a huge, companies have incentives financially, tax-wise, to get rid of plastic. So all the plastic that can be eliminated, but it's not reusable plastic. They get a bonus for it. So it's kind of a good thing. And sometimes the expense of cardboard, adding extra cardboard, can we reduce the size of the box? So here you can see how this is done in simulation. Again, because you've designed a package in CATIA package design, it's correct. And in Simulia, it's gonna show us what's gonna happen if you've got the real data in here. And when I say that, you kind of need to know what it's gonna go through. One way of doing that is literally throwing an accelerometer in a package and shipping it and finding out. And then you get some real data on how far your package has to ship. So I don't want that one into that. But we can look and see here, shrink wrap. How much shrink wrap do you need to use? We have not enough. Are we wasting it? It's important. How hard of a stop can it take before it goes? You can keep increasing that until it does. And so that's kind of an important step, because remember, none of this stuff's bolted on. It's all just held on by plastic there. So the things that are unseen are in a truck. So those are just some things I wanted to show you. And I have this kind of a quick video that just kind of gives you a snapshot into the world of simulation. We're going to do a full webinar on this as well, which is going to show us, from building and creating a package and package design all the way through the different simulations that it might take. And just to give some ideas for those of you in manufacturing, if you're doing injection molding and things, the stuff can be designed from a level that gives you a realistic view of what's going to happen. Blow molding, dropping something on the floor. Of course, we saw the shrink wrap and the crush testing. Filling things up with material, hot material, cold material. What happens when, you're trying to run something down an assembly line, or filling it up. This is all possible in the same platform. All of the models and designs that we do in design move right straight forward, and there's a tear design on a package. You can see how much force it takes to rip it open. If they drop that, will it rip on its own? And these are all things that you need to know, and can save any company a ton of money by not finding out the hard way on what happens there. So that being said, I'll go to. I just wanted to look for our upcoming webinar. We don't have a date for it. It's going to be called Sustainability and Digital Transformation. It's going to be about packaging simulation from design through simulation. That being said, we have another poll. If you'd like to start the poll, can you?
Yes, it's up in their screens.
Yes, Again, if you have any topics that are not included in this list, please go ahead and put them in the chat. We're going to take this data and we're going to create the next session of CATIA University classes based on the input from the attendees here. So if there's something specifically that you haven't seen so far in these university series, please let us know. These are some of the things that we thought maybe would be of interest and some of the things that we're intending to show in the future. So please go ahead and complete the poll if you would. And while you're completing the poll, I didn't mention this earlier, but if you have any questions, please go ahead and stick them in the chat as we go along. And we're going to come to a time here in just a minute to go through the questions as well. So.
Yeah, and Susan, I want to take a few minutes to talk about our next webinar when we complete the poll, because it's a really important one. It's on electrical. We'll show the slide and we'll talk about it.
Okay. Do we have the results back yet, Kenya?
Yes, thank you everyone for participating. You can see the results in your screens now.
Oh, fasteners, Glenn, you'll be happy about that.
Oh yeah, that's one of the other applications.
20%, kinematics, complex kinematics, 40%, fasteners, 80%, MBSE, 20%, and data-driven versus document-centric solutions is another 20%. Thanks, everyone. So it looks like fasteners was the clear winner here for one of the next sessions.
Yeah.
So again, if you guys have any questions, please go ahead and put them in the chat window right now. Glenn, I do have a couple of questions. Whoa,
okay. Let's take care of that first.
The question says, you showed packaging for food products. Does this apply to me? I'm in aerospace.
Well, yeah, I would say yeah. So I come from aerospace, and I can remember, as the head of the engineering department, we got requests all the time from shipping. Now it depends on what you're shipping, right? Sometimes your bigger components and products like that, you're designing crates and not as much actual boxing. But if you're shipping, maybe pre-assembled components for the F-35, you probably want some boxing and packaging. And I know we used to let the people down in the packaging department just figure that out, but really it should be done from a design level, in my opinion. So it's easy to do. It just doesn't take a lot of time, and I think it's a worthy endeavor for any industry. Again, it depends on the products you're shipping, but because when you get into, if you're just creating, then you would use just a regular design app. You wouldn't use the packaging boxing app, but you could still simulate that. So that's an important thing, is you can look at what happens if you were to create something up and use a material to support it. You could probably simulate that and find out if that'll make it there without getting scratched or dented. Because I know in aerospace, you can't have a scratch on anything. So that's one way of looking at it.
Thank you, Glenn. We've got more questions.
Okay.
Is there a bend allowance specification for corrugated box material?
Not in there by default. I mean, they have one that if you choose corrugated, you get the default. So it comes default, but is it going to be right for you? You're going to have to test and see. And I say that because, like, you can use it and it's going to work somewhat accurately, but if you're getting right down to the finite, you may want to calibrate your material model. Because the material model, the way that's built is basically, like, the material model that we use was built from, two pieces of surface and a wavy piece in the middle. So we actually created that, and you get a stiffness value from it for your material. So you're actually testing against a stiffness value when you're testing. So it's kind of I guess, I don't know if that's too complicated of an answer, but it's the way that works. Hope that answers.
Yes, thank you, Glenn. There's a couple more questions. How can this solution be helpful if I create automotive parts? That's kind of similar to the other question.
Yeah, I mean, again, depending on what type of automotive parts, if you're if you're shipping stuff out in boxes, it can help you. You may be generating a lot of waste, or maybe in material, or maybe if your products are getting damaged, it can be put a stop to that by running it through this process and simulating it. Simulation is key to that. Creating boxes, designing boxes. A lot of times they come in standard sizes, so you may be using standard sizes. But if you've got something you're shipping, 5,000 of, it probably pays to design the box. So I hope that answers that.
Thank you, Glenn. The next question is, does CATIA package design have nesting included, or do I need to output another nesting application?
That's actually a great question. No, it comes with it. It's part of the application. So if you get packaging design, by default, you're nesting. So, and I think it'll put out a DXF file. If I'm not mistaken, you can put out a DXF file. So you can send it right to a printer that has a knife printer if you want to, and it'll work.
Okay. And then the last one I have is, what is ModSim? Do you buy a design package and then analyze it in a different simulation package?
So that's a great question. So the 3D experience is one package. So for example, some of our roles have both simulation and design in them. And so when we talk about ModSim is technically, it can be done in separate softwares. You're modifying the product through the active simulation. So for example, let's say you have a thickness of cardboard and you have a certain amount of weight you got to put on it. So you can modify the thickness of that design through optimization on the 3D Experience platform. And the way that's done is you make your design, you parameterize. Let's just say that thickness number is the only thing that you have parameterized. That's all you need. And so they take that and they bring it right into Simulia, which is on the 3D Experience platform. There's no conversion. There's no download. You literally open up the exact model, and your finite element model gets built right on top of or underneath the tree on the model that you designed. So the guy that's doing the simulation is has your parameters exposed. So then once they simulate it, it can be run. We have something called Process Composer that you can bring it in and optimize it. You could say, well, I want this box to hold 10 pounds. And so you can run an optimization and it'll look at what the minimum or, the minimum thickness you can use to achieve that. And so that's kind of the idea of ModSim. Or the other idea might be functional generative design, which is a CATIA application that uses Simulia. And what you do is you come in and you say, this is how much space I have to design the part in. And then you put in the features that have to be there, like maybe you have some holes and some surfaces. And you load a constraint on there. And you say, this part's going to hold still, these parts are going to pull, this is how much strain is going to be on it. And Simulia will come back and tell CATIA, this is where you need to draw these. In many cases, it's like looks like tubing or pipes, right? But it's taking the strained areas and it's going to put material there. And it's going to say, this is what you need to make this strong. And from there, you can morph and change that design into something. So instead of, traditionally on automotive, aerospace, everything, we make brackets, bulkheads, things like that. We do it the way we know how to do it, right? We draw, we draw in an area, we say, this bracket's got to be shaped like an L and it's got some holes in it. And, that might not even be the best way to make that bracket because of the way the strain is. Maybe instead of it being an L-shaped bracket, it should be a crooked T-shaped bracket, And so that's what ModSim does for you. ModSim takes all the intelligence that's already built into the computer and tells you what you have to have. And from there, you can take that design and make it into something. So for example, a great application for this would be if they're up on the, they're up circling on a space station and they've got to 3D print something. Well, they want to use as little plastic as possible, and they want to have this component, or metal. They want to have this component absolutely hold a certain amount of weight or strain. They can just make that and use the minimum. It's design of the future is ModSim. And so the more you get into the 3D experience platform and see that using one unified data model is what allows this. And so, to talk about even, our next webinar coming up, electrical, all your data is in there so that you can start to use some automation to design and draw things and manufacture them. I used to do CNC programming, and every time you'd get a part, you'd go in and you'd program the part. When in today's world, that data can be taken and reused, and so you don't have to do all the programming yourself. You can let the computer run and generate some of that. So it's minimizing work and maximizing efficiency. And I hope that wasn't too long-winded, but that's my take on ModSim. I'm a big advocate of it.
No, that was a good answer, and I think it kind of, I'm guessing that's what you're going to be presenting on the plug you gave earlier for the sustainability session.
Exactly.
It's going to be more ModSim. Yeah. Okay, so we'll be sure to get that out to everybody so you can get a deeper dive into the ModSim part of it. Next slide.
We'll release that date. But, Susan, what I did want to mention is that we do have our very next webinar, which is in the university series, and I'll go back to the other slide, is the CATIA University Wire Harness and Electrical Engineering. We have two presenters from Dassault who are going to present this. And, just like we talked about reusing data for ModSim, electricals come so far where, if you know what your specifications are and you know where you need to route it, there's a lot of automation here. You pick end to end and the routing is done for you. Now, I know I'm making that sound simple and they're going to make it look simple. But again, when you get into electrical and electrical design, you have an electrical harness and, how's that thing laid out on a pin board to be wired, and right down to that information. The connectivity between the needs, the design, and the output, and then the result are all connected now in the 3D experience platform. So that's why it's so important to show everybody, because what is possible is tremendous. It's just a matter of getting in and doing it. So that being said, Susan, I'm going to hand it back over to you, and if there are any questions, I'll answer them. So feel free to keep feeding questions in. We have a little bit. So feed questions in. I'll let Susan talk about the gift card and maybe the winner. If you're ready to do that, Susan.
I'm ready. I don't see any additional questions. So if you have any questions, go ahead and put them into the chat right now. But we're going to go ahead and move forward and announce the lucky winner of the $50 gift card. That individual is Brian Powell from PRC. Brian, if you could flip back, Glenn, to my email address.
Oh, yeah.
If you could send me an email, I will hook you up and get you the $50 gift card.
Congratulations.
So, congratulations. Please be sure to reach out. And again, we want to, reemphasize that we're having another webinar next month on the 16th, the week of Valentine's Day, regarding electrical design and wire harness. So keep that in your mind and hope to see everyone there next time. Thank you so much, everyone. Thank you, Glenn. Thank you, Kenya. And thank you, all attendees.
All right, and I'll just mention and close with be looking for. We'll advertise it as a follow-on to the packaging design as the sustainability. It's going to be a deeper dive. It's going to be a little bit more technical, and it might be a little bit longer. So
I would imagine.
But we're going to go through it step by step and actually show you some stuff that we've really actually created for the demonstration. And we did, both drop testing, stack testing, and just so you can see, what's possible and why you might use this. So be looking for that, and hope to see you on the wire harness and electrical. Thank you very much for coming.
Thanks, everyone. Have a great rest of your day. Bye-bye.